All right, welcome to my version of doing Chapter 2 test. So hopefully you can watch and learn and check all your answers and do better next time you take it. Okay? So first off, it is December, so Chris Kringle's the one who's taking this test. And who's Miss Toomer? She was my favorite teacher growing up, my third grade teacher. Her first name was actually Fanny, so it's kind of, we used to chuckle and say, Fanny Toomer, hee hee hee. Anyway, she was awesome. Anyway, here we go. Number one, multiplying fractions is what? Multiplying fractions is easy. Why is it easy? You don't have to worry about common denominators. You just take that number and you multiply the top. So in this case, 1 times 2. And the bottom, 6 times 5. And you will simplify if you can. Since both those numbers are even, 2 and 30, I know 2 goes into both. 2 goes into the top one time and goes into 30, 15. Just so you know, you could have cross-canceled, and that basically simplifies it before you start by recognizing that 2 goes into 2 once and goes into 6 3 times. Then you would have had 1 times 1 on top, which is 1, and 3 times 5 on the bottom, which is 15. Same answer, right? Just 2 different ways of getting there. Okay. Didn't matter much on that one because those are small numbers. Now, this number is a mixed number. It has a whole number, the 1, and a fraction. So I need to change that to an improper fraction before I multiply across the top and bottom. The method we like to use is called the C method. And that's when you're multiplying the 9 times the 1, the denominator times the whole number, and adding the numerator. So 9 times 1 is 9, plus 4 more is 13. And what's that go over? The denominator will never change. Basically what I did is I took that 1 whole, which is 9 ninths, and I added the 4 ninths, and got me the 13 ninths. That's how that works. Okay? All right, but now I can multiply. I got 1 times 13 on top, 8 times 9 on the bottom, and I'm done. I can't simplify that one. On to number 3. Both of these are not improper fractions, they're mixed numbers. We want to change them to improper fractions, so I'm going to use the C method on both of these. And 4 times 1 is 4, plus 1 more is 5, so that becomes 5 fourths. 8 times 8 is 64, plus 5 more is 69, so that becomes 69 eighths. Again, the denominator won't change. And now I'm going to multiply across the top, multiply across the bottom, and on this one I get 5 times 69. I can come over here and do this. You could do that in your head by saying 5 times 70 minus 5 times 1, or 5. 350 minus 5 is 345. But you're always safe to do this. 5 times 9 is 45. I put the 5 there, carry the 4. And 5 times 6 is 30, plus the 4. So I get 345 on top. And I get 4 times 8, or 32 on the bottom. Now, they want the answer in simplest form. And that also means they don't want an improper fraction for your answer. So to simplify this, I'm going to divide the bottom into the top. 32 into 345. That looks like it's going to be hard until you realize I'm starting with 32 into 34. Well, that's almost the same, right? It goes in one time. Make sure that 1 goes above the 4. Otherwise, you're saying that it goes into 3 one time, and it doesn't, right? All right, whenever I put a number here, I'm going to multiply. 1 times 32, and then whenever I multiply, I subtract, and whenever I subtract, I bring down the next number. Okay, now 32 fits into 25 0 times. Got to put that 0 up there. Now, nothing to bring down. I'm going to make this into a mixed number by bringing the remainder on top and the number outside the denominator, the divisor, on the bottom. You get 10 and 25 32s. Okay? All right, on to 3 division problems. Okay? And we like it when they're multiplying problems, multiplication, because multiplying fractions is easy. So I like to show you how to turn it into an easy problem. Okay, and the way we remember that is we remember smell my feet. Okay, sixth graders seem to remember that. Some kids like to turn it into smell my flowers, right? SMF. What does that really mean? Well, it's a mnemonic way to remember something. And the way we remember is SMF is same, multiply, flip. Same. I leave that first number the same. 2/3 doesn't change. It's easier if you leave it the same, right? And remember, we want to make this easy, so that M is going to stand for multiply. But I'm not going to multiply by 7 over 9. I'm going to flip it to 9 over 7. Remember what that flip means? That's called the reciprocal. Okay? Now, I can simplify this before I start because 3 goes into 3 and 3 goes into 9. So I'm going to say 3 goes into 3 once, 3 goes into 9 3 times. And now I'm multiplying across the top. 2 times 3, across the bottom, 1 times 7. Boom, I'm done. Not bad, huh? Okay, on to another one. Now, in this one, I got to turn that 6 into a fraction, and you could turn any whole number into a fraction. Boom, boom. Just put a 1 under it. Now, smell my feet. I'm going to leave the first number the same. 4/9 is 4/9. I'm going to make it easy by having this be multiply instead of divide. And I'm going to flip that second number. So instead of 6 over 1, I'm going 1 over 6. Now I can simplify a little bit because this is even and that is even. So 2 goes into both 4 and 6. How many 2's fit into 4? 2. How many 2's fit into 6? 3. So on top I have 1 times 2. And on the bottom, I got 3 times 9. 2 times 2 over 27. 2/27 is my answer. Boom. On to the next one, right? All right. Again, both of these are mixed numbers, so I'm going to turn both of them into improper fractions with the C method. 3 times 1 is 3, plus 1 is 4. So that's 4/3. And 6 times 1 is 6, plus 1 is 7. So that's 7/6. And then smell my feet. Right? The 4/3 is going to stay the same. I'm going to multiply instead of divide to make it easy. And then instead of 7 over 6, I'm going to do the reciprocal of it. I'm going to flip it. 6 over 7. Now I can simplify this because 3 goes into both 3 and 6. So I'm going to say 3 goes into 3 once. And how many times does 3 go into 6? Twice. And I multiply across the top, I get an 8. Across the bottom, I get 7. That is improper. 7/7 is 1 whole. So I'm going to say that's the same as 1 whole. And if I use 7 of those 8/7 to make my 1 whole, I got 1/7 left. 8/7 is the same as. You want to double check this, you can always use the C method. If I did the C method on 1 and 1/7, I go 7 times 1 is 7 plus 1 is 8, and that goes over 7. That's what I started with, right? So I must have simplified that correctly. All right, evaluate the expression. I have subtracting and adding, and order of operations says that those are kind of equal, so I'm just going to go from left to right. When I add or subtract decimals, it's important that I stack them and line up the decimal. Now, this is one of those ones I don't like so much. You can do it wrong and get it right because it comes out, they both come out to 3 places past the decimal. Actually, all 3 of these do, right? I kind of like when they mix it up and it really lets you know if you know how to do it. Now, I can't take 5 away from 1, so I got to borrow. And 11 minus 5 is 6, 6 minus 3, 1 minus 1 is 0. The decimal comes straight down when you add or subtract. I can't take 1 or 7 from 1, but I'm just going to say 21 minus 17 is 4. I could go borrow and get the 11 minus 7. Well, anyway, that's the first part. Now I have to take this and add it to the 8 and 356 thousandths. Make sure I line up those decimals. 6 and 6 is 12. Carry the 1. 9, 3, the decimal comes straight down, and I have a 4 and 8 is 12. So I have 12 and 392 thousandths. Boom, cruising along, right? Now this one I have parentheses, and parentheses takes cuts in front of everything in order of operations. I got to do that first. Okay, so I'm going to add these two first. Again, stack them, line up the decimal. Now it looks a little weird because this one only came out to the hundreds place, or 2 spots. This one comes out to the thousands place, or 3 spots. If it looks weird and it bugs you, and it bugs me, add a 0. You're allowed to. Now it doesn't look so weird. 9 and 0. 9 and 3 is 12. Carry that 1. Decimal comes straight down, and I got 5 and 429 thousandths, or 5.429. Now, don't forget, I have to take that and multiply it by the 3.7. Okay? Now, when I multiply decimals, my first step is I pretend there's no decimal. And then I go multiply. So I'm thinking this is 5,429 times 37. 7 times 9, 63. 14 and 6 is 20. 28 and 2 is 30. And 7 times 5 is 35, plus 3 more is 38. Now, before I multiply this 3 times the 9, the 2, the 4, and the 5, I'm going to put a placeholder, because that is 3 tens, or 30. And then I'm going to cross these out so I don't get confused. Now I go 3 times 9 is 27. 3 times 2 is 6, plus 2 more is 8. 3 times 4 is 12. Carry that 1, and 15 and 1 is 16. Now I add these. And now I got to go back and say I pretended there was no decimal, but there was 1 there, and there was 1, 2, 3 there. So really there were 4 numbers to the right of the decimal. So I have to go back 4 spots in my answer. 1, 2, 3, 4. So my answer is going to be 20.0873. Let's go ahead and rewrite that over here and circle it. Okay? All right. 12 equal payments, and you pay a total of $1,524. How much is each payment? Well, this many times the payment is that much, so that much divided by the 12 is going to be equal how many payments? So I'm dividing. I got to go 12 into 1,524. Now, how many 12s fit into 1? None, but 15 one time. Make sure that 1 is above the 5. 1 times 12, and I subtract. And then I'm going 12 into 32. That's only going to fit twice. That's 24. And then when I bring down that 4, I don't know if you can see, that's at 84. And 12 goes into 84 7 times. Perfect fit. So $127 is each payment. On to 10. Now, I tried to give you guys some hints this week, having a couple of problems on the board reminding you the word quotient. That's usually the last one of the 4 major operations that kids learn. The sum is the answer to an addition problem. The difference is the answer to subtraction. The product is the answer to a multiplication. And the quotient is the answer to a division. So I'm going to divide this by that. How many times does 200 go into 3,808? Well, it won't fit into 3, won't fit into 8, fits into 380 only 1 time, right? Because 2 times 200 is 400. So I subtract, and I get 180. Then I bring down that next number, and it goes into 1,808 9 times, because that's 1,800, almost perfect fit, huh? All right. Now, I have a remainder. I could make it a fraction, but I think on this they want you to make it a decimal. Add a decimal and a 0 and bring it down. Now it goes into 80 0 times. It's important that you put this 0 here. You can't just keep adding zeros without doing anything. I put a 0 there because it went into 80 0 times. 0 times 200. When I subtract now, when I add a 0 and bring it down, it's going to fit a perfect 4 times. So my answer to this, the quotient of 3,808 and 200 is 19 400ths, or 19.04. Okay? Dividing. Which number goes in the box? This is why I say the first number goes in the box. What do I mean by in the box? When I go to divide, this is the box. Okay? Now, 12 will not fit in. But before we got a decimal, let's deal with that. If there's a decimal in the box but not outside, all you got to do is, you're done. Now you just start dividing. 12 goes into 9 0 times. I'm going to go ahead and put a 0 there. 12 goes into 93 7 times. 7 times 12 is 84. And I subtract there. I got a 9. Bring down the 4. And will it fit another time? 84, no, plus 12 be 96. I'm going to say 7 again. Get 84 again. This time I get a 10. And I got an 8 when I bring it down. Now, 12 fits into 108, a perfect 9 times, right? So, the answer on this one is 0.779. On to the next one. First number goes in the box. I'm going to put it up here. Second number outside the box. And I got a decimal outside the box. It's against the math law to divide with a decimal outside the box. So to avoid the math police, I have to get rid of it. And I wrote it in pen. How do I get rid of it? All right, remember how to get rid of it. You have to move it to the right until it's all the way on the right in front of that number. But remember, if I move the decimal outside the box, I got to do the same thing inside the box. So if I moved it 2 spots over, I got to move it 2 spots over here. Okay? Now, don't be silly and start dividing with 4 decimals and all those scoops. That's a confusing looking problem. Spend a few seconds to rewrite it. What's my problem now? 14 into 81 and 2/10. Okay? So, now I'm going to bring the decimal up and say 14, I know 14 times 5 is 70, because half of 14 is 7. That's 7 times 10. So I'm going to say it goes into 81 5 times. And then when I subtract, I get 11 and bring down that 2. And now I think 8's going to fit on here, right? Let's just double check 14 times 8. This is what I do. This is how I solve things, right? 32, carry the 3, and 8 plus 3 is 11. Boom, perfect fit. So this is going to go 5.8 or 5 8/10. I'm not going to multiply and get to 112 and subtract and get 0. I'm going to know I'm done. Okay? All right. First number inside the box. Now, a lot of kids, a lot of adults, a lot of people think this is 2 digits, that 3, so this must be outside. No, always tell yourself which number goes in the box. 18. Which number's out the box? That's the second number. I got a decimal outside the box, so I got to get rid of it. How do I get rid of it? Move it 2 spots to the right in this case. And if I did it outside, I got to do it inside. Now, if there is no decimal, remember it always lives on the right. That's why we put it there. We don't need it once it's on the right. So if there isn't one there, this is where it was. I got to go 2 spots, and in here we say fill the egg carton. Now, don't be silly, right? Go rewrite this. Now I'm going 375 into, won't fit into 1, it won't fit into 18, it won't fit into 180, it fits into 1800. How many times? Well, I'm estimating it first, and I think this is going to be 4 times. Not sure, right? I think it's going to be 4 times. Because if I double that, I get 750. And 750 and 750 is 1500. So I just multiplied that in my head, didn't I? 4 times 375 is 1500. Okay, so I get 300 when I get done. Well, I'm not done yet, so I'm going to add a decimal and bring it up. Right? I'm allowed to add decimals and then add a 0. After I have a decimal, I can add zeros, because 1800 is the same as 1800 and 0/10. And guess what? This will fit into this perfectly 8 times, right? Because if I double this, I get that. So it was 4, got me that. 8's going to get me this. And you can come over here and do 3.75 or 375 times 8 just to make sure. But you're going to get 3,000. So my answer to 13 is 4 8/10. This pot contains, sorry, my computer is taking a nap on me. It went to sleep because I didn't wiggle the mouse. I got to make sure we're still in here. Yeah, it looks like we still are. Sorry for the interruption. Here we go. A pot contains 32 ounces of soil, and you want to plant, you use 3 1/8 to plant 1 herb. Is there enough soil to plant 10 herbs? Okay, so what are we doing here? I got to take this and divide it by that. That's one way to do it. Okay? Another way is to say, if I want to plant 10 herbs, and each herb takes this many ounces, I can multiply and see if my answer is smaller than 32 or not. And if it is, I can do it. If it's not, I can't. Okay? So I can do it both ways. I'm on this one. I'm going to go ahead and multiply the 10 times 3 1/8. Right? And again, C method. So I get 25 on top, 8 on the bottom. Turn the 10 into a fraction by putting a 1 under it. Now I can simplify and say that 2 goes into 10 5 times, goes into 8 4 times. So on top I got 5 times 25, that's like 5 quarters, that's $1.25, 125, 25, 50, 75, 100, 25, and then 1 times 4. Now I have to divide the bottom into the top. How many times does 4 go into 125? Well, it goes into 12 3 times. It'll go into 5 1 time. And I got something left over. I can either divide with a decimal or make that my numerator. Well, guess what? To do 10 pots of herbs, it takes 31 1/4 ounces. I got 32. Do I have enough? Yes. Now, you could have said 32 over 1 divided by 3 1/8 as well. All right? And see if you have your answer is 10 or more. Okay? I'm not going to do it both ways on that one. I'm going to have you learn that other way. Okay. On to the second page. You have 4 cups of raisins. The recipe calls for 3/8 of a cup per serving. How many full servings can you make? Well, I'm dividing. 4 divided by 3/8, and I'm going to make that 4 over 1. And then when we divide fractions, what do? Smell my feet. Same. Leave that 4 over 1 alone. Multiply so we can make it easy. And then the reciprocal or flip that 3/8. When I multiply that across the top, I get 32. On the bottom, I get 3. And then I want to divide the bottom into the top. And when I go 3 into 32, I'm saying that goes 10 times. Sort of cheating, putting 2 numbers up there. And I got some left over. But all I really need to know, I don't care about the fraction, because they want to know how many full servings. Okay? If I want to get the fraction, you want to see what it is. Remember, your remainder goes on top, divisor on the bottom. 10 2/3 servings is what you can make, but you're not going to make 2/3 of a serving. You can make 10 full servings. So your answer on that is 10. People want to make it 10 2/3, but it's 10 full servings. All right, you run 9 3/5 miles, and you run 1/4 of that on a hill. So part of this was a hill. 1/4 of that is the 9 3/4. So I got to go 1/4 of 9 3/4, and what does of mean in math? You're multiplying. Got to use the C method on this. 36 plus 3 is 39. You got 39 on top, 4 on the bottom. Uh-oh. That's 3/5. Whew. Barely got that, didn't I, huh? So that's not going to be 39. It's 9 times 5 is 45, plus 3 is 48 on top. 5 on the bottom, and I'm taking 1/4 of that, right, or 1/4 times. Ooh, glad I caught that. Now, 4 goes into 48, so I can cross cancel, okay? I'm going to do that in other card ink just so you can see this, because this is getting a little messy. So I'm going to say 4 goes into 4 once, and into 48 12 times. And now when I multiply on top, I got 1 times 12, and on the bottom 1 times 5. Now, that's how much of it was on the hill, right? That was 1/4 of it. Not really to scale, but that's 12/5, right? Now, that's the 12/5, but you run down a slope for the last 3/8 of the hill. The hill was 12/5. I'm doing of again. I'm doing 3/8 times 12/5. Now let's simplify, because 4 goes into 8 and 4 goes into 12. 2 times on that one, 3 times on that one, 3 times 3 is 9, 2 times 5 is 10. What are my units? Miles. 9/10 of a mile is how much was downhill. Okay. All right. Evaluate the expression. I'm just getting the answer. This is order of operations. I got to make sure I do parentheses first. 3/5 divided by 1/8. Dividing fractions, what do? Multiply by the reciprocal, or as I like to teach the kids, smell my feet. Keep that first one the same. Multiply instead of divide, and flip that second one. Oh, I like that, except for I wrote it wrong, huh? This is 3/5. Keep that the same, I said. Don't change it. I went and changed it. 3 times 8 is 24, right? And 5 times 1. So the parentheses ended up being 24/5. I got to multiply 3/4 times that. 3/4 times 24/5. Can I simplify? Yeah, 4 goes into 24, huh? So we say 4 goes into 4 once, and 24 6 times. Now on top I got 3 times 6. On the bottom I got 1 times 5. Now I have to take this and subtract it from 9. But 18/5 is an improper fraction, so I'm going to change it into a mixed number by dividing the bottom into the top. How many 5s fit into 18? 3. What's my leftover? My remainder is 3. That's going to go on top, and the 5 on the bottom. So now I have 9 minus 3 3/5. I like to write those vertically. And this is a little tricky because I can't take 3/5 away from nothing. Right now I got 0/5 up there. What do? I borrow. Borrow from the 9, make it an 8. Now here's where you don't just put a 1 there. I borrowed 1 whole because I needed some fifths. How many fifths is equal to 1 whole? Think about it. Yeah, 5. So I borrowed 5/5. I had 0 and I borrowed 5. Now I got 5/5. I can take away 3/5. That leaves me with 2/5. And 8 minus 3 is 5. So my answer on this is 5 2/5. Circle that so we know how to find it easily. On to the next one. Okay, look at this one. It's a rectangle. Okay, and the length is 8 and 32 meters, 3/200 meters. The width is 3.1 meters. What is the approximate? That is a big word that you like to see. Why? Because that means I get to estimate. Now, perimeter, I want you to always circle that because that is the distance around. And the E in estimate means you're supposed to make this problem easy. 3.1 is too hard. Let's make it 3. 8.32 is way too hard. Let's make it 8. And now I can add 8 and 3, and another 3, and another 8. Go all the way around is 11, which is 22. What are my units? Meters. That's my answer. Okay? Make it easy. All right. When we're looking for patterns, what I like to do is find out the difference between consecutive numbers. What is the difference between 4 and 3.6? Well, I'm going to subtract. That's 4.0, and I get 0.4. What's the difference between 3.6 and 3.2? I get 0.4. What's the difference between 3.2 and 2.8? Gotta borrow. 12 minus 8, 0.4. Oh, check it out. We have a pattern. Each time I'm subtracting 0.4. So what are the next three numbers? Well, 2.8 minus 0.4. 8 minus 4, 2 minus 0. 2.4 is the next one. What is 2.4 minus 0.4? 2, or 2.0. And what is 2.0 minus 0.4? Gotta borrow. 1.6. So 2.4, 2.0, and 1.6 are the next three answers. Okay? All right. Container holds a maximum of this amount. Right now there's two things in there. Right? There's a 2.65 in there, and there's a 10.8 in there. Okay? How much room is left? What do? Got to add these. So 2.65, writing underneath that, I added a 0 next to the 8, so it doesn't look so weird. 0 and 5, 8 and 6 is 14. The decimal comes straight down, 1 and 2, and 1. So I have 13.45. It holds 17.5. What's left? I need to subtract. 17.5. Again, line up those decimals. Now it looks weird. This place, it's key that you want to make sure that you add that 0 so you don't bring that 5 down. All right, I got to borrow. 10 minus 5, 4 minus 4. The decimal comes straight down, and 7 minus 3. So I got room for another 4.05 pounds. Ask your science teacher why it's LB instead of PD or something, right? All right, last one. This one was a tough one, okay? And you're basically saying this happens every this many days, this happens every this many days, and it's kind of like a least common multiple problem. When's it going to happen again, right? So I just said, okay, well, the 4.5 and a 4.5, that makes a 9. A 3.75 and a 3.75, that makes a 7.5. 7.5 and 7.5 makes 15. 9 and 9 makes 18. And we're getting close, right? If I do another 2 of these, another 7.5, I'm getting 22.5. And if I add another 4.5 to the 18, I get 22.5. So this was a weird problem, but in 22 and a half days, this is going to happen again. Okay? Wish there was an easier way to do that. Least common multiple with mixed numbers. Weird. All right. Hopefully this helps.